Hello all. In the last video, we have completed regarding physicochemical properties and bulk characterization aspect and solubility analysis aspect of the preformulation. Now it's time to study the third aspect of preformulation, that is a stability analysis. In that we will study about the solution state stability, solid state stability, drug excipient compatibility. Along with the physicochemical properties of the drug, the stability analysis of the APIs should also studied before the formulation development, as it helped to develop a stable, safe, and effective dosage form, which are the three major key parameters or key considerations of the formulation development. So the stability studies include both the solutions and solid state experiments under the various conditions for handling, formulation, storage, and in vivo administration. The solution phase stability, which is the effect of pH specifically on the stability, which is important in the development of both oral and parenteral dosage form. Okay, so at this time of studying the solution phase stability, we need to know the effect of pH on that particular solution. The acid sensitive drugs, which are protected from highly acidic environment from the stomach by coating it with the suitable polymers. Solid phase stability depends on several factors like temperature, pH, humidity, hydrolysis, and oxidation. The next parameter, which is we should explore during the preformulation studies, the compatibility, drug excipient compatibility. So the compatibility test play a very important role in the preformulation studies of the oral dosage forms. The problem arises because of the specific interactions of the drug with the other drug substances and with the excipients such as preservatives, stabilizer, dyes, and flavors present in the formulation. And it may result into the harmful metabolic product formation or harmful byproduct formation, okay, which will create instability problems in the dosage form. So it is important for the formulation scientist of a new drug substance to know with which excipient he can work and which he cannot. So here is one flow diagram which help us to know that how the drug excipient compatibility studies should be performed. Okay, so we can take a drug and excipient with the 50% of the mixture with the 1:1 proportion, and we can use this sample for the DSC analysis, that is a differential scanning colorimetry analysis. Into that instrument, after this analysis study, if there is no interaction between drug and excipient, we can recommend this excipient. But if there is an interaction observed between the drug and excipient through the DSC scan, DSC analysis, if there is an interaction, then we need to go for the thin layer chromatography study for the separation. And if there is a significant breakdown observed between the drug and excipient, then we need to go for the alternative excipient. We cannot recommend this excipient. So in this way, we can perform the drug excipient compatibility study. Now, after studying the all aspect of preformulation, we should know some analytical methods which are generally used to study some physicochemical properties. Such as microscopicity, spectroscopy, chromatography. By using these analytical techniques, it helps us to know about how to measure that physicochemical property and how it will affect on the drug during the formulation development. Now, the first analytical technique, that is a microscopy, which is in this technique, substances are examined under the microscope. It gives information about shape, thickness, particle size of the drug molecule. And this method, by using this method, we can study the crystal morphology, difference between polymorphic character of the molecule. Then UV spectrometry. When organic molecules in the solution or as a liquid are exposed to light in the visible and ultraviolet light regions of the spectrum, they absorb the light of a particular wavelength depending on the type of electronic transition that is associated with the absorption. The spectrometry can be used to study the enzyme reaction and to evaluate the effect of drug on that particular enzyme. The study will give us the information regarding the unsaturation or saturation of the compound. Here in this picture, you can study how the UV spectrophotometer will act. The second analytical technique, that is IR spectroscopy, the study of the interaction of electromagnetic radiation with the vibrational and rotational resonance within a molecular structure, is termed as IR spectroscopy. IR has the ability to differentiate the isomers groups such as cis and trans double bond compound, and this IR spectroscopy will give the information regarding functional group present in the new drug molecule or the API. Here you can see the IR spectrophotometer. This is a source which will emit some light radiations with specific frequencies, and which will go through this sample and will get a graph spectra, which will help to analyze the functional group present into that compound. The next analytical technique is the X-ray diffraction. When a beam of a non-homogeneous X-rays is allowed to pass through a sample, the X-ray beam is diffracted and it is recorded by means of a photographic plates. The single crystal X-ray provides the most complete information about the solid state, or specific crystal form, or the polymorphic form. It is used to differentiate the amorphous and crystalline forms. Thus, it is a very important technique while the drug development process. Here you can see the X-ray diffraction process. The thermal analysis, differential scanning colorimetry and the differential thermal analysis, that is DTA, are the particularly useful in the preformulation studies for the study of purity of the drug, polymorphism, which kind of polymorph is there present in the API, solvation, degradation, and excipient compatibility. It measures the physical or chemical changes of the drug molecule. The thermogravimetric analysis, which is used to detect the existence and the stability of the solvated drug molecule. The next analytical technique, that is a chromatography. In this pre-formulation studies, chromatographic techniques such as thin layer chromatography, HPLC, GC carrying a major role in the pre-formulation. The major advantages are the direct analysis of aqueous samples, high sensitivity, and the specific determination of a drug concentration, separation of the drug from the impurities or the degradative products. So here we have completed the pre-formulation with their different aspects, that is a bulk characterization, solubility analysis, and stability analysis. You can refer these books also. See here, as you studied in detail the pre-formulation, okay, you have it will help definitely to develop a stable, safe, and effective dosage form. And these analytical techniques are help you to determine this physicochemical properties. In the examination, if there is a question asked on pre-formulation, along with the parameters, along with the physicochemical properties, you have to also know, you should know, and you should write the specific analytical techniques used to measure that particular physicochemical properties. Thank you.